Okay, hi guys. So I will fill out some more of the review material and do some of the other review material, and then you will be on your own. And yeah, okay. Let's take a look at 62. This is a U substitution. 5x plus 3 du equals 5 dx. So we can rewrite this as u 1 over u du. That's just natural log plus c. Final step. Rewrite this as natural log 5x plus c. Do something similar for 5. 1. This gets rewritten as because the integral of e to the x, or e to the u in this case, when it's just a single variable, is itself. And finally, just substitute back in terms of x. Derivative, remember what is the derivative of log of u, where u is some function that depends on x. It's u prime over u. So we'll just start off by putting u down. And then we'll put down u prime. Okay. Let me see if there's something else that I want to actually give commentary on. Maybe I'll do this one, even though it's kind of standard, just because the tangent line is a good problem to know how to do. Ooh, black again. Okay, so taking the derivative, nothing magic here, just know how to use the chain rule. Derivative of the inside. The value, then we want to evaluate at the x, at x. That is given in the problem. 4, 2. 2 times 2 is 4, so 2 to the 4th is 16, so 16 times 2, 32 times 5, too damn much. Oh, no. Close one. 5 times 32.60. That does seem like a lot. Is that right? 32. Okay, wow, it is. And then we'll give our answer in terms of the slope. Then we'll plug in x naught will be what we get from the question, and then we can simplify this out a little bit. You may or may not have to do this part where you simplify it all the way down into slope-intercept form. I'm just doing that now to show you how you do it if you had to. Okay, 57, 7677. You can see the answer to that in the document, so I'll leave that alone. 58. Maybe it's good to see this one actually worked out. Okay. Use the second derivative test. Use the second derivative test. Here's a fast food restaurant. Profit is modeled by P. Use the second derivative test to see the optimal number of hamburgers that should be sold. I'm going to find the maximum profit. Yeah, remember, whenever you hear relative extrema, maximum, minimum, optimize, you're going to want to use the second derivative test. Okay, so P prime of x equals to x. So what is going on here? All that's going on here is the simple power rule. So not, that's where all this is coming from. Equals this guy one, two, three, yeah, so right around zeros, and you can just plug this into your calculator to get 32,500. Then analyze this to make sure it is in fact a relative minimum. That is just saying plug into the second derivative test, or plug into the second derivative. The second derivative is we want to maximize profit. So anyway, this is always negative. Don't let that trip you up just because there's no variable. It's still negative. So x equals 32,500 is the answer to A. The answer to B is whatever P of 32,500 is, which is 97,725 dollars. Green for money. Okay, anything else? Okay, 80, 81. I might have went over these in the second section, but the first section didn't see them, so I'll go over them again. So 80 is pretty nice. 80, all we have to do is remember that area means integral. So integral, yeah, so this question is asking what is the area of this blue region. So remember, the area between blue and the area between the graph and the x-axis is given by the integral. And so we want to find the area underneath this function. Between these x values. So that's all that one is. That one's relatively simple. 81 is more of a troublemaker. So for 81, it's given the following functions and their graph setup. The definite integral is probably what that says. That represents the area of the shaded region between two curves. You must show your algebra for finding your bounds. Okay, so the first thing I want to do is say, how do we find our bounds? Well, the bounds are where these two lines intersect. So what that literally means is the y value of f of x and the y value of g of x are the same for a given x value. So we're going to set these two guys equal to each other because that's what that statement means. Okay, and then do a little work. Negative x squared plus 5x. Yeah, that's what we need. So factor out the x, I'll leave the negative sign, plus 5. So the roots are 0 and 5. What's nice is that okay, that's not our answer, but I'll put in blue. So show that's special. What's nice about this picture is, okay, so this one is definitely x equals 0. This one, it's maybe a little bit harder to tell exactly what it is, but it definitely should be between 5 and 6, or 4 and 6, which 5 is, so it looks like we got that right. And now the only other question after we set up our bounds is, which one of these two functions on top? Well, this red one is curving, and this blue one is straight. And quadratics curve, and linears are straight. So f is on top because this function is f, this function is g. Put f and g of x in your answer, and anyhow, you should probably put the actual guys in there. I don't know how much work they want you to show. I don't write the exam, but I don't know, man. Like put a nice little bit of work in that. I think they'll like that. Okay, so anyway, this is as simplified as it can be. This is more than enough work, and they should be satisfied with that. And maybe I'll do 82. Actually, let me just move on to the next review because we'll probably see some stuff like 82 on the other review. Okay, it looks like you should check out consumer and producer surplus, which was the last topic on the last set of notes. So I'm going to guess there's going to be one question about that on the final. So keep that in mind. Yeah, there definitely will because you mentioned it. Okay, so 1 through 7. Okay. Standard, very good question. Choices may be used more than once, so let's look. All we need to do for this question is remember that the definite integrals are the signed area between the function and the x-axis. So where is -3 to -1? It's all underneath the x-axis, so it is going to be the negative. Sorry, I'm just pulling up the review. Okay, good, still recording. Um, oh gosh, dude, I'm so freaking tired. Okay. Anyway, okay, where is -1 to 2? Okay, so what they're doing here, and you have to realize this, is that this area is obviously and evidently much smaller than this one. So this is going to be like 5 plus -50. It's going to be a very negative number. So that's how I know it's going to be negative. 2 to 4, just positive, because 2 to 4, all positive. 4 is 0 to 4. Shit. Oh, gosh. I just thought about it. I should have just given you the other one as paper and asked you to do the. That was a much better way to do this. What I should have done was I should have handed out the long one on Monday and said, okay, yeah, you guys can skip around and just do the ones you don't know how to do. Fuck, that would have been much better. Okay, all right, well, there's still this. I didn't say that, by the way. Okay, 04. This is a much smaller area than this one, so it's going to beat out that one, and it's going to be mostly positive. Yeah, so let me maybe sketch this out. We'll call this region 2, this one region 1, and this one region 2, this one region 2, this one region 1. It goes from 0 to 4. So region 1 is much smaller than region 2, so region 2 is going to dominate, and region 2 is positive, so that's why the whole thing is positive. 0, negative 3 to 0. Again, just focus on just pick whichever one is the bigger area, and the sign of the bigger area is going to win out, so that's why it's negative. 0 to 2. 0 to 2, negative. Negative 1 to 0, positive, because it's just, yeah, positive area. I'm going to guess like she won't put 0. So yeah, I would say never guess 0. Um, because that would require you to, well, okay, you should only ever put 0 if there are two that look the exact same, because otherwise she wouldn't put it there. Like if she had a hump that looks like that and a hump that looks like that, and these are supposed to be. Hang on, let me. Okay, well, I won't do it, but you get the idea. It's like that, like roughly the same area. That's the only way it could ever be 0. To have correct notation, what needs to be included in this expression before you integrate? Ah, excellent trick question. Plus dx, or add dx to the end. Because I know a lot of you guys are going to think, oh, what do we always have to include plus c? You will erroneously or incorrectly select plus c because you think that should always go with the integral, with indefinite integrals. But in this case, they specified before you can integrate, not after. Okay, sweet. When finding the indefinite integral, one should let u be that indefinite integral. What should one let u be? Okay, so never select the whole gosh darn thing. That's always going to be wrong. Yeah, this problem does not require u substitution is the answer, because what this problem requires is simplification. So you'll you'll divide both of them by t, or you can factor out the t from both of them, cancel with the denominator, and you'll get dt. Find that one. Okay, so fortunately they all include plus c. So yeah, this is just a know your definitions type thing. Don't select logarithm. Don't apply the power rule. Select the correct answer. And remember, this guy, each of the x, he doesn't change when he integrates. Yeah, don't, divide by 0, trying to do trying to do some sort of a weird power rule here, all bad ideas, just remember the answer. We have a -1. You have a -1, it should become log. Okay, 12, good problem. It should be, you can rewrite this as this, and now it makes more sense. Because what is the integral of any constant? The variable that you're integrating with respect to plus c. So that's why the answer is this one. Yeah. Okay, little side note, the only time the answer will be just plus c is if you're integrating 0. Sorry, let me double check that. I don't even know if that's right. I don't know if, or maybe it's just 0. Okay, so it's 0 plus c, which is just plus c. So that is correct. Find the indefinite integral if the problem requires plug in. Oh, so it's saying what it's trying to get at here is, does this problem require u substitution? If so, fill in the rest of this, and the answer is yes. So when we want to do u substitution with an exponent, we always just set u to be whatever is in the exponent, or whatever, yeah, in the exponent. So this is the procedure for u when we are integrating with respect to, with e. So the derivative of u with respect to x is 0.1, so then it's du is equal to 0.1 dx. So the integral, sucks. So if we work this out, it'd be e to the, oh gosh. Okay, so we only have a dx, we don't have a free 0.1, a free, free, free 0.1. So we'll move it over to the other side. Get dx. And then when we substitute in, we'll get EU du over 0.1. So our answer is u 0.1 plus c. But we replace u in terms of x. So we get this guy for our answer. 14 is just another, another one of that. So just if there's a problem like this on the exam, just write it. Write that guy twice, the same text. Oh wow. Okay, so in this case, we're going to put x over this box because the integral is just this guy, and he gives us increase the exponent by 1, divide by the new guy, and then that gives us u. Okay, so this is a good time where to look at something. We notice here we have a polynomial with 2 terms. Here we have a polynomial with 2 terms. it would be good to check and see if we can integrate this. And in fact, we can if we let u be x to the fourth minus x squared. Yeah. Okay, so du, take its derivative, and I guess we'll do it down here. And then again. Okay, so I mean, I understand how this could be frustrating. It's like, how did I know to let u be that? But it's just like I'm going through in my head our integration rules, and it's like, well, this doesn't really seem like a power rule because it's not something, not not something like this. Fourth, it's not something like that or some fifth or anything. Um, so you just have to try and be on the lookout when you see like some sort of a pattern, try and exploit it. Because really there only is one pattern that no, sorry, there are two patterns. There are, can I find something and its derivative in the integral, or is that not there? If that's not there, move on to simplification. That's basically it. No, log 4x. You. Oh man, I'm just actually losing it thinking about how much better it would have been to do it. To like go through all this today because it seems like, oh my god, it really seems like they're going to hammer they're going to hammer this idea now. Okay, well, I don't know, you guys. I mean, if you're watching this, I guess it's fine. If you're not watching this, well, you're not watching this, and you may be in for a rough, rough situation. Okay, well, anyway, all right. Oh, okay. Du, yada yada. Let me see what they want you to fill out here because it's not in its most useful form if we just leave it like that. Mean squared 2x 2x. Okay. Anyway, 2x. So yeah, we don't do that. Who are we replacing? So blue, blue, to green, green. Now look how the integral changes. 7x is no. Whoopsies. So that's who's getting eaten. It's the x, and the dx is getting replaced by du over 2. U to the fourth du divided by 2. Now this is a simple power rule problem. Fifth divided by 5. Substitute in, forget plus c. Substitute in terms of x. Oh, by the way, if I skipped them, it's because I thought they were kind of easy. Or I was just, kind of going to let people email me, uh, about them. So plug that in. That's how you get that. This is, yeah. What is this? Simple power rule. I'm increasing by 1 from 4 to 5, dividing by that guy. Yeah. Oh, she might say you need to use it. Okay. Yeah. Yeah, so it's when you have I didn't talk about this fully, but like when you have just a scaling and it's just x plus a or x plus or minus b or minus a, you don't really need to use u substitution, even though it's not one of the rules we learned. Even though it's a little bit different from the power rule that we learned, which is just x to the n. It can also be x minus the n. And maybe I don't know who needs to hear this, but the reason this is fine is because remember what the integral signifies. It signifies the area over the curve. So all this is doing, or the area between the curve and the x-axis, whatever. All this is doing is shifting that area left or right. You can play around with this by, on Desmos. You can take some function and you can do x minus 1 or x plus 1 on all of them. It'll just shift the function left or right by 1 or 2. So that's why this doesn't change anything. So anyway, it's totally fine to integrate like so. We'll just apply the G.I.B power rule. So increase by 1, divide by that number, but remember that's the same as multiplying by the reciprocal. Then you get that. Definitely. Oh my gosh, what? This is too much. No, not really. It's probably fine. So it's just term by term. Oh my gosh, what a beautiful integral. Sorry, I'm being weird. Um, it's just, I don't know, it's kind of nice. So we're going to notice we're going to increase all of these by 1 with the 1 there, 0 there, so it's going to become x. So 5, 5, so you might start to see a pattern here. I think I actually might have done something similar in quite a few of the in-class assignments or the homeworks. So then a lot of these guys cancel. There's just alternating polynomial of like decreasing degree. Okay, I've done enough integration. Email me if you have a question about 21. Okay, anyway. Okay, so we're going to need to start by labeling your first step as y equals f of x, showing the proper integral. So I guess we'll want to set it up like that. And this is just the simple, okay, I'm not, when I say simple, by the way, I don't mean simple as in easy. I mean it's called simple because it's easier than the chain rule version of this problem. Squared plus minus 2x. Okay. I'm going to finish this up in a second, but I need your first. Cannot pause. Recording. Yeah, I'll just stop.